All right, so how do we start with this question now? So note that P and Q are on both sides of AB and AC respectively, such that PQ is going to be parallel to BC. Well, how do we go on about this? You have AB and AC, and PQ are on both sides, so that PQ is BC, parallel to BC. This tells you that APQ is similar to ABC. And you can just use ratios. You know that AB is 12, PB is 9, AC is 18. This is 3, so it's 1/4 of this. So from here, you understand what I'm saying? This is 4.5. That length. So subtracting this gives you 13.5. Alright? This is just ratios, alright? All this is just ratio bash. Alright? Oh, so the answer is 4.5 or 9/2. Right? This is just finding the ratios, doing similar triangles, and then you find the answer. Alright? Let's go on to 5.25. The side lengths of a triangle are 4 centimeters, 6 centimeters, and 9 centimeters. One of the side lengths of a similar triangle is 36 centimeters. What is the maximum number of centimeters possible in the perimeter of the second triangle? I'll just have to try this question and tell me your answer to chat. In private message, please. Let's get started with this question. So, how are we supposed to approach this? Well, the side lengths of the triangle are 4, 6, and 9, alright? One of the side lengths of the similar triangle is 36. What is the maximum possible centimeters possible in this perimeter of the triangle? This is basically trial and error, alright? All these sides are divisible by 36. They divide into 36. So we gotta test out which ones, when you add it up and find the ratios and you multiply them, give the most. Let's start with 6. Let's say 6 is corresponds to the 36. Then it should be 24. And this one should be 54. Alright. You get a total of 74, I believe. No, no, no. 114. Right, that's max. The total is 114. If it was 4, if it corresponded to 4, it would have been 36, 54, and 81, which would have corresponded to 171. And you can check, and that's going to be the greatest. Because we want to find the maximum ratio. Ratio is the maximum, is the most important. Because basically, if you add all this perimeter up, they're all going to amount to the same thing. They're all going to be 19 multiplied by some multiple, alright? So from here, you can basically multiply a multiple, find the greatest multiple, or my greatest factor in order to get it. For example, in this case, it was 9. Then you'd get the maximum number of centimeters possible in the perimeter of the second triangle, alright? Let's move on to 5.26. What's wrong with this diagram shown below? Alright? So this is gonna have to go with similarity, right? I was gonna try this question and tell me answers through chat. Chat. Let's get started with this question. So, what's wrong with the diagram below? Well, it's obviously the ratios, alright? We can see it's 6.5 to 2, which is not equal to 6 to 3.5. But it literally is angle similarity though, which contradicts. So the sides are not the right. The sides are not the right lengths. All right, now let's move on to 5.27. Find DE in the diagram below. You guys have a try on this question and tell me through chat in private message, please. Let's get started with this question. So, how are you supposed to approach this? Well, notice that we want to find DE in this diagram, all right? So, how would you come to find DE? Nothing comes up to mind really good, all right? I don't see anything that can be related to. Well, let's look at this. What if we extend E? Let's see what happens when we extend E. Well, we noticed that EC is 11 and CA is 9, right? And we know that AB to AE is 6 out of 20 is the 3/10, and AC to the AD is also 3/10. We can find similar triangles, right? We can also try looking at this triangle. Maybe it'll lead us something, but as of right now, it does not look like it leads to something. Maybe we can show that they're parallel lines and so on. But we want to trying to find D, and I don't see how we can go through after that. All right. Now, what if we consider AB and AE? AB to AE, we have AB to AE's 3/10, and AC to AD. It's also 3/10. And then we have AB divided by AD is equal to AC divided by AD. And we also know that BAC is equal to EAD. They're the same angle, which gives us ABC is similar to AED. Of course, it does not look like it, but you gotta look and see. And then ED is to BC is equal to DA to AC, so DE divided by 13 equals 35/9, so you get 133. 133 is equal to DE. Alright. Now let's move to 5.28. Why is this diagram below shown below impossible? I'll just got to try this question and tell me through chat. Alright, let's just get started with this question now. So why is this diagram shown below impossible? Well, obviously, one way to look at this is that notice that they're similar because of A. So we have corresponding sides now. However, however, since these correspond, by the way, this angle, opposite of this angle, so this side, since it's opposite that angle, should be over here. This angle should be over here. However, that's not the case, right? So that's why this diagram is literally impossible because the similarity checks out, but like the angles are not there in the right places. Well, it's true by angle, but like the angles are not in the right places, which causes it to fail. All right. So 1 to 5 429. In the diagram below, find WY and YV. Now notice that. Now notice that this is a bunch of similar triangles in reality. Right? Since we know this is right triangle, so WYZ is similar to YVZ and so on. You can easily see that YZW is 180 minus what WYZ minus what YZWZ equals 90 minus YWZ. So on, bunch of angle chasing. But at the end, you'll get WYX is similar to ZYW. Alright? Through a bunch of angle chasing. And we have WY divided by YZ is equal to XY divided by WY. Substituting, you get WY squared is equal to 24. Square root, it just gives you answer as 2 squares of 6. Alright. So that's it for today's class. I hope you guys have a wonderful night and a wonderful weekend. I'll see you next week. Bye.